And welcome, students, to the course. We are going to start right off with asking what is a computer, because obviously that is the central theme of this course. And in order for us to do that, we first need to define what a computer is. So let's get started here. In this course, we'll be examining a lot about the hardware side of computing. Before we do that, we first need to define exactly what a computer is. And our definition for a computer that we will use is a device that processes the data according to a set of instructions. Now, under that definition, let's ask, so what makes a computer? You can probably name the following as computers relatively easy: desktops, laptops, tablets, and smartphones. These are all devices that we usually think, yeah, that's a computer. Especially, like desktops and laptops, because, we rarely think of those as PCs. And you might even think, okay, a tablet, I can see that, and even your smartphone. But, according to our definition, computers are not restricted to these categories. So, let's stop and think about what's not a quote-unquote traditional computer. What may not fit into one of those four categories? As mentioned on the previous slide, desktops, laptops, tablets, and smartphones are what many people think of when asked what a computer is. However, computers are not restricted to these. In the following slides, we're going to examine some non-traditional computers, not all of them. There's so many different things that we could go through that wouldn't necessarily have relevance to this course, or the field of computing is so large that we won't be able to list everything. And define in greater detail also what makes a traditional computer. So let's start first with the desktop. This is one of the traditional computers. A desktop computer is a computer that's intended for regular use at a single location. So that means that you can't just pick it up and move it someplace else and keep working. You have to pick it up, unplug everything, plug it all back in. Like a desktop, you have a monitor, tower, all that stuff. The tower of a desktop computer used to be placed underneath the monitor, but it's often stood vertical next to the monitor today. In fact, if you look at how desktops used to be in the past, they were pretty much all in one machine, and the tower was inside the monitor, was inside the tower casing, and they were all one physical machine. And there is a specialized form of desktop called all-in-one that integrates all the PC internal components in the same case as the monitor. You don't see as many of those simply because it takes away one of the biggest strengths of desktops, which is having the ability to easily upgrade, expand, or customize the internal components of the computer. And that's one of the biggest selling points for desktops, is the customability, the ability to easily go in and add more slots to stuff. And when you go to an all-in-one, it's a lot harder to do that. All right, laptops. We're going to define those as a portable personal computer suitable for mobile use. It has many of the same features that a desktop has, but also has a pointing device, which is known as the touchpad. And it has the advantage of being able to be away from the wall with a rechargeable battery. Compare that to a desktop, which has to be plugged in. Now, there are several additional subgroups of laptops, netbooks, which have largely kind of phased out. They still exist, but a lot of them have evolved into other forms. Ultrabooks, which are super thin with solid-state drives, and 2-in-1 devices, which is a hybrid of laptops and tablets. All right, so tablets, which are, of course, are fully known as a tablet computer. The tablet is a one-piece mobile computer. They replace the traditional mouse and keyboard with a virtual keyboard and the finger or stylus. And that's really what kind of helps separate a tablet from a laptop, is that you don't have a physical keyboard necessarily anymore. Instead, now everything is virtual on the screen. Larger than a smartphone, tablets are typically around 7 inches or larger. You can get smaller tablets than 7 inches. They have 5 inches, 6 inch tablets. But a lot of times those aren't really regarded as true tablets, because usually a tablet is at least 7 inches. And when we're talking 7 inches, we're talking the diagonal measure of the screen. Now, tablets have actually been conceptualized as far back as the mid-20th century, but the device would not actually become affordable nor popular until 2010 with the release of the iPad. The iPad is really what helped kick it off. Now, believe it or not, Windows actually first tried to unsuccessfully sell a tablet in 2002 for businesses, but it failed to find widespread uses. So when people say Apple was the first or Android was first, actually Windows tried first. And there have been companies before that, but Windows was the first one to try and make a PC-like tablet, but it didn't really take off. Now, Android would be the first one to come out with their dominating platforms back in 2009. But the issue was that many of the manufacturers waited until the honeycomb version of Android in 2011 to actually release the Android tablet, which pretty much gave Apple a head start on the market. Because remember, Apple came out in 2010, Android really started taking off in 2011. So that whole year difference made a huge head start for Apple. All right, our last of the major traditional categories is smartphones. Our definition for a smartphone is a mobile phone built with a mobile operating system that has more advanced computing capability and connectivity than that of a feature phone. Feature phone is things like a slider or a flip phone. Originally having the combined features of things like a personal digital assistant and a mobile phone, later models have added functionality such as media players, compact digital cameras and camcorders, and even GPS units. And of course, that's not even the scope of what smartphones can do today, especially with apps. Now, these modern devices include high-resolution touchscreens. They're, in fact, some phones that get to a certain resolution where the resolution is beyond where the human eye can really handle, so they don't really develop that more on phones. Compact processors and web browsers that can display both standard and mobile-optimized web pages. And remember, the difference with that is, with a mobile-optimized web page, if you try to look at your additional web page, through a phone, you have to go and zoom in, whereas mobile rearranges the elements and stuff so it fits better. Now, 90% of the market today is dominated by Android or iPhone devices. All right, so now we're into our non-traditional stuff. So let's talk real quick about wearable tech. The simplest version of a computer at this level, a digital watch. This is an example I can always easily give because it truly is, at its heart, a computer. Remember, our definition of a computer is just a device that processes data according to a set of instructions. That digital watch is going to probably process time. It might have a stopwatch feature. It might have some kind of timer feature. The difference between timer runs up, stopwatch runs down, this sort of thing. It is a computer. That being said, computing in the wearable field has evolved to be able to do things such as monitor heart rate, answer calls, display on non-traditional surfaces, and more. So, you don't have to necessarily have a physical screen. You could project out onto a screen. There is also some wearable tech where they have, it's almost like a slap-on bracelet for you to wear, like your phone surface and stuff. Some of the stuff is not as good as they might advertise, and so that's why you don't see it. And also people are like, well, why would I want that? Why do I want to pay money for that? But these are all different examples of this wearable tech. Now, we aren't actually going to talk too much about wearable technology in this class. But with the inclusion of augmented and virtual reality technologies, the pioneering of this field will continue to evolve. All right, let's talk about some simple and complex machines. All right, you may suspect this computer behind this, which of course is the microwave. All right, think about your popcorn button. It's a preset set of instructions. You also may know that there are computers behind these. All right, so you have a tractor over here. All right, modern tractors are not simply just mechanical. They have onboard computers that do everything from monitor your engine speed, run diagnostics, have GPS, run pre-programmed instructions, and even your car also has onboard diagnostics. Computers help handle various tasks now, and everything from your popcorn button to handling automatic braking systems. Again, this is not a topic we're going to explore greatly in the scope of this course, but it is something we just want to kind of mention, that there are computers behind almost everything that we do now today. All right, you can't talk about technology without talking about robotics. And you may immediately think of a computer as something kind of like this. So a robotic arm, all right, working down at the factory line, as picks up the parts, put it on the assembly line, off it goes. However, robotics paired with the fields of artificial intelligence have been working to create computers that are more self-aware. They can interact with people and get that more natural human response. So they're not necessarily just running off a script. Like if someone asks it a random question, the AI can go ahead and create an answer for it to generate. Now, this course will touch on some of the basic circuitry concepts that are used in robotics, but robotics is not the primary focus of this course. Right? We're not really going to focus hardcore on robotics. We're more interested in knowing about what makes things tick. And that concludes our notes, folks. Until next time.